Hello everyone. In this video we're going to be solving a differential equation, an easy one with some interesting properties. So we have dy over dx, which is the first derivative of y with respect to x, equals y plus x squared. I'm going to go ahead and show you the solution. We're going to be looking at different pieces and then we're going to put it together, and at the end I'm going to show you what Wolfram alpha gives us. Okay, let's get started. So we have dy over dx, which can be written as y prime, the first derivative, and then I'm going to set it equal to y plus x squared. So here's what I'm going to do. I'm going to put every term that has y in it on the left-hand side. So I'm going to write it like y prime minus y equals x squared. So this is a non-homogeneous solution with an x squared on the right-hand side. If we had a 0 on the right-hand side, then this would be a homogeneous equation. So homogeneous equations are obviously easy to solve, but anyways, let's go ahead and do the following. First of all, we're going to look at the homogeneous case. We're going to find the homogeneous solution, and then we're going to find a particular solution for this equation, and then we'll put it together. Okay, so that's the plan. First of all, to find the homogeneous solution, we'll set the right-hand side equal to 0. Now, this is a really basic, easy, one of the first differential equations that you'll encounter. Y prime equals y. Now, think about it. The derivative of which function equals itself? And there's only one function that satisfies it, besides 0, of course, right? And 0 is always a solution in this case. But in general, if you're looking for a solution, it will be like e to the power x, right? E is a special number we just talked about, I think it was yesterday, Euler's number. So that's the idea. So this equation is satisfied by e to the power x because the derivative of e to the x is itself, right? And you can do it millions of times. But how do we arrive at the solution? There's a couple of ways to go about it. You can kind of write it like this, and then you can kind of use a differential operator like d minus 1 times y, which indicates the derivative of y minus y itself, and then d minus 1 set it equal to 0, you get d equals 1, which means this is y equals e to the power x, because this is supposed to be 1x, and that 1 comes from the d. Anyway, it's a long story, so to keep a long story short, I'm going to tell you what it is. Let's get rid of all these details, and the solution to this equation is y equals c times e to the power x. Why c? Because c is a constant. You can use k if you want. If you don't like c, you can also use z or b, to be or not to be, whatever. But I'm just going to use c because it's very common. C times e to the x, because the constant doesn't matter. Make sense? Derivative of c e to the x is c e to the x, and it's equal to c e to the x, which is function itself, and this is the derivative. So it works. Great. So that is the non-homogeneous solution, right? I mean the homogeneous solution, the other way around. So let's go ahead and look at a particular case. How do we make sure that this function satisfies our equation, original equation? Because if I differentiate it and plug it in here, it's not going to work because I have an x squared. I don't have a 0. So here's what we're going to do. We're going to take this c e to the x, and we're going to add something else to it. Like what? I'm going to go ahead and add like a quadratic, because my result is quadratic, so it makes sense if my particular solution looks like this, right? Ax squared plus bx plus c. Now here's what's going to happen. When you differentiate both sides, you're going to get y prime, and then we're going to plug it into the original equation, into this one, and therefore we're going to find the solution. Let's go ahead and do it. Y prime. The derivative of c e to the x is just c e to the x. That doesn't matter. The derivative of the quadratic is more interesting, 2ax plus b. And then our equation was y prime minus y equals x squared, remember? So let's go ahead and plug everything in. C e to the x plus 2ax plus b minus c e to the x plus ax squared plus bx plus c. Now, c e to the x doesn't matter because it's always going to work with the homogeneous case, so it's going to disappear. Okay, but I still wrote it. Now, this is supposed to equal x squared because we have x squared on the right-hand side, right? So let's go ahead and do polynomial equation. Negative ax squared. Now, I have 2ax and a minus bx, so that's like 2a minus b times x. And then I have a b minus c as our constant, right? b minus c. I kind of underline as we go, so it's easier to handle. So we have this polynomial equation, which means that the coefficient of x squared must be the same on both sides, which indicates negative a must be 1, which indicates a must be negative 1. Awesome. What about b? There's no x on the right-hand side, so the coefficient of x must be 0. And then from here we get b equals 2a, which is negative 2. Awesome. And then the constant term, there's no constant term here, right? There's no constant. So b minus c must be 0, which indicates b equals c, which indicates c is equal to negative 2. And I got all the values of a, b, c, and it's actually easy as a, b, c. Allow me to say that. So now our solution was in this form, remember? So we're going to go ahead and replace a, b, c with numbers, and we're going to get our general solution. If you want to put a y sub g here, you can. For the general, I don't really care. So c to the x is the homogeneous solution plus ax squared. But a is negative. Come on, why did you put a plus sign? I didn't know. Okay, minus negative or minus plus my negative 1x squared plus bx, another negative. And then plus c, another negative. Okay, everything is negative here. Very negative situation. But anyways, that's the answer. So this is going to be the general solution. And if you want to check it out, you can always plug it into the original problem. But we already know it is going to work because that's how we found the a, b, and c values. So let's go ahead and take a look at what Wolfram Alpha gave us as the solution. And yay, we got the same answer. As a bonus, I also gave you the slope field. Look it up, kind of interesting stuff. Slope field, if you're taking an AP exam in the United States, slope fields are important for especially BC calculus. And anyways, this is kind of fun stuff. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.